everyone, this is Miss Graham, and today we are going to be completing the 32.4 practice, which is on the calendar. So go ahead and download that if you haven't already. So we are going to be taking notes and watching this video going through each of our problems. We are really going to summarize what we've been doing the past 6 days in class, looking at solving by factoring, solving by square roots, and solving by the quadratic formula, and identifying the best way to solve each problem given. After that, we are going to practice solving all 3 ways. Let's go ahead and start looking at the directions for problems 1 through 6. As you can see, it's asking us to identify and justify the method you would use to solve each of the problems below. But it also says do not solve. So let's go through the 3 methods that we've learned the past couple of days. So we first learned how to solve through factoring. The next method that we learned was square roots. And the last method we just learned was the quadratic formula. Now, all 3 of these methods to solve whenever we have an x squared term in our problem, some of them are good to use for different occasions, some of them are not good to use on certain occasions. So we're going to look through examples 1, 2, and 3 and talk about what would be the best method. Looking at number 1, we can already see that we are having 2 binomials being multiplied. It's already in factor form. So it really would be easy to use factoring to solve this. Doing the zero product property so that each of these 2 expressions is set equal to 0 and solving for x from there. So what we're going to do is we're going to say the best way for number 1 would be through factoring. So we're going to say factoring. And the reason we're going to give is because it's in factored form already. So it's in factored form already. Great, now we can go ahead and look at number 2. So we can see that even though we don't have all terms on one side, we could easily move the 72 over by subtracting it. But then all we have is a term that's squared as well as a constant. There's really not a trinomial there. There's no y term. So the best method to use would be by taking square roots. So we're going to go ahead and say square roots would be the best way to approach this. Now, it's best to use this method since there's no y term. Alrighty, let's go ahead and go on to our 3rd problem. So looking at this, we can see it's a trinomial. Awesome, so it's probably not best to use square roots. We would have to use factoring or the quadratic formula. So looking at this, we would want to find what multiplies to, let's say, negative 30 adds to negative 1. We could use factoring in this case, we could, but for me, I actually would prefer the quadratic formula. A lot of times when our a value in front of x squared is greater than 1, that's a lot of the times we try to use the quadratic formula because this can be tough to factor sometimes. Again, you could use factored form. I'm not saying you shouldn't use factored form, but I think the quadratic formula would be easier. So let's go ahead and write quadratic formula. And we're going to say since our a value is greater than 1. So here's what I'm going to have you start to do. I want you to look at numbers 4, 5, and 6, and I want you to see what would be probably the easiest method out of the 3 that we learned up here for you to solve by. So go ahead, pause the video, give yourself time to try all of these and distinguishing which method you would use, and then press play when you want to check your answer. All right, let's go over our results. So for number 4, I said it was easiest to solve by factoring since you can take the greatest common factor out of x and be left with a monomial times a binomial. Therefore, you can use the zero product property pretty easily. For number 5, I had to think about this for a while, but looking at this, I would say square root, doing that method is the easiest since we can isolate z by subtracting 1, dividing by 8, then taking the square root, and then adding 5 to our answer. For number 6, I would say the quadratic formula after we move over the 7x after we subtract it. It's really hard for us to factor this. Figuring out what multiplies to 22 but adds to 7, there's really no way that we can do that in factored form. So the quadratic formula is really easy when we have some of those tougher problems. So now that we've practiced distinguishing all of the ways, right? All 3 methods of which one would be the best to approach. We can now not just identify the method, but we can go on to problems and practice all 3 methods at the same time. So we're going to do kind of a mix of all of them. Now, something I do want to point out is, looking at, let's say, number 1, it is already in factored form, so it's easy to solve. But if we were given the original trinomial, we could also do it as the quadratic formula. Say here, number 3, like I said, we're given the original trinomial, we can do the quadratic formula, but you can also factor. Either way, you will get the same result. So keep that in mind. We get the same result, the same outcome, either way we choose for number 3. But sometimes, one method is the only way it'll be easiest to solve each of these problems. So let's go ahead and go down to number 7 and 8. Now, I decided to kind of copy down the 3 methods that we are going to use so we can outline them here and see how we can practice. So let's go ahead and look at number 7. So think about which method will be easiest to solve with. I hope you're thinking factoring because that's exactly what I'm thinking. So for me, I'm going to put a little f on top so we know that we're factoring. And we're really already having our result in factored form. So we're applying the zero product property, meaning that 2 expressions that are multiplied together that equal 0 means that one of the results will have to equal 0. One of the expressions will have to equal 0. So let's go ahead. And for our first expression that we set equal to 0, let's add 5 to both sides so we know we get an x value of 5. And then for our other expression that we set equal to 0, let's go ahead and subtract 6. So that way we have x equal to negative 6. So those are solutions to number 7. Let's go ahead and look at number 8. So think about which method would be the easiest to use here. All right, so looking at this, I would probably want to use square root. So I'm going to abbreviate maybe an SR up at the top for square roots. Now, again, with square roots, we don't have to get all terms to the same side. What we can do is we can start to isolate by dividing by 2. So we have y squared equals 36. And then we take the square root of both sides. So y will be equal to not just 6, but it'll be equal to a positive and negative 6. So we can write our answer like this. Or if you want to write out the positive 6 and the negative 6 separately, you can do that as well. Let's move on to number 9. So look at all 3 methods. Which form would you like to do? Great. All right, let's look at quadratic formula. Perfect, quadratic formula. So let's go ahead and start off labeling A, B, and C. Remember, our B is -1. So we're going to take x equals the opposite of B. So the opposite of -1 is a +1. Then we're going to do plus or minus. The square root of, well, that's going to be B squared, so -1 squared. Plus, minus 4 times our A value of 6 times our C value of -5. And that's all going to be divided by 2 times 6. So if we keep working through here, we have 1 plus or minus the square root of, well, this is going to be 1. When we multiply all these together, what do we get? I think we get a positive 120. So we really have 1 plus 120 over 12. If we keep working downward, we have 1 plus or minus the square root of 121 over 12. And we actually are able to take the square root of 121. So I know I'm running a little bit out of space. I'm going to keep doing my work to the side. So I have 1 plus or minus square root of 121 is 11 over 12. Then I'm going to move over here a little bit. So that way I can still divide my answer up into 2 parts. So x will equal 1 plus 11 over 12 and x will equal 1 minus 11 over 12. So 1 plus 11 is going to be 12 over 12. That's going to reduce to 1. So we know x will equal 1. Now 1 minus 11 is negative 10. So we have negative 10 over 12. We definitely have to reduce that fraction. So that'll be negative 5 over 6. Nice. So looking at that, that's looking pretty good. Awesome. Now keep in mind, we could have also done factoring for this. If we get a result that's not like a crazy, insane, irrational number decimal, we can definitely be able to factor this. Now, something that you might have noticed if I zoom out. Maybe some of you saw this, maybe some of you didn't. I move that over. Hey, numbers 7, 8, and 9, weren't they like the first 3 problems we did? Actually, they are, right? So we practiced identifying what's the best method to use. Obviously, it's not always going to be in this order. They can mix up the order of the problems down there, but we were able to analyze it and practice it and see what we could do. So, nice job. We're going to go ahead and start to go back down to numbers 10 through 15. So keep in mind that we can put our methods over here, kind of refer to them off to the side if we need to, use it as a resource. So we're going to keep practicing doing 10, 11, and 12. All right, so let's look at these. Awesome. Okay, so think about what would be the best method for 10. I say it's factoring as well. We can factor out an x, so that way we have x times x plus 7. That means we can use the zero product property. So really, I'm setting the expression of x plus 7 equal to 0. Well, x equals 0 is already equal to 0. Nice. We already have x isolated, so we got that value. When we subtract 7 from both sides, we should get x equal to negative 7. Looking at our next problem, number 11. All right, I can see that I already have this kind of binomial squared. It's probably going to be best to do square roots method. So I'm going to start off by subtracting 1 to both sides. So I have 8 times z minus 5 squared equals 72. I divide by 8, so that way I have z minus 5 squared equals 9. Take the square root of both sides, so I have z minus 5. That equals positive and negative 3, plus or minus 3. So now when I add 5 to both sides, my answer of z will be 5 plus or minus 3. Remember that plus or minus goes along with the 3. Now I'm going to zoom in just a little bit. Ooh, maybe not that much, but I'm going to move over to the side here. I'm going to rewrite this as 5 plus 3. And I'm going to rewrite this as 5 minus 3 because I actually want to figure out what those numbers are. So 5 plus 3, that's going to give us 8. So we're going to have a solution of 8. And then when I do 5 minus 3, I get a solution of 2. Again, something you might have noticed if we go back up to the previous problems, 10 and 11, they're like 4 and 5. So probably number 6 is going to be like 12. So right now, here's what I want you to do. We know that 12 is going to be quadratic formula. We got that down. Awesome. All right, I want you to go ahead and practice quadratic formula on number 12. Don't forget to move the 7x over. Go ahead and play the video whenever you're ready to check your answer and work. All right, I scooted on over number 12 to show my work all right here. As you can see, we end up with a negative number under our square root. And right now, what we know of our real number system is we cannot have negatives under the square root. So we know that there are no real solutions that are possible. Awesome. Okay, let's go ahead and zoom on back to 13, 14, and 15. All right, so for 13, 14, and 15, you are going to have the choice of which methods you would like to use on each of these problems. Now, I'll tell you that we might not necessarily use all three methods throughout these three problems. Maybe we'll use a method twice. Maybe you could use one method for all three. I mean, I'm going to give you an opportunity to work on this now, to pause the video again, to really take the time to analyze these quadratic equations, right? We're going to take the time to look at these, see which method we want to do, and then when you come back and check for your answer, we're going to see if we did the same method, or maybe we tried different methods, but we're going to see if we get the same result. So pause the video right now. Try all three problems, 13, 14, and 15. That's right. Don't just write down what I have here. I want you to try it on your own and check back in when you're done. All right, let's go ahead and go over these three problems. So I bet for 13, most of you may have picked the quadratic formula since our a value is more than 1. However, I decided to choose factoring because I wanted to show you that it's still possible to get the same result either way. Now, usually when we've factored and gotten our results for x, they've usually been whole numbers. I wanted to show you factoring this time because we're not always going to get whole number results. When I come up with my binomial here and then use a zero product property, I do get -2 as my whole number, but my second binomial, right, that expression 2x minus 3, I have to use 2 steps to solve for x. I first add 3 to both sides and then divide by 2, so that way I get 3/2 as my answer. So you should have gotten the exact same thing if you use the quadratic formula, same as those two answers. Now for 14, this was really hard to factor. There was really nothing that multiplied to 14, added to -7. Yeah, not really anything, so that's why I picked the quadratic formula. I plugged it into my formula of x equals my opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But however, I got to this part right here where I had a negative under my square root. Wah wah, that means no real solutions possible. Now looking at 15, again, we could have used quadratic formula, but I thought, hey, this is very possible to factor, right? So when I end up changing my original trinomial into two binomials being multiplied, there's actually 2 ways I could approach part of this. Keep in mind that these binomials are the exact same. So when I do the zero product property, I just have to set one of them equal to 0 and solve because it's my solution of 5 that will be repeated twice. Now, looking at this, we could actually take this step right here. Think about how writing the binomial twice is the same as saying that binomial squared. This looks like the square root method, right? Where we could take the square root of both sides. The square root of 0 will still just be 0. I mean, plus or minus 0 is not going to change anything. We know 0 is a neutral number. So when we add 5 to the other side, we just get one solution of 5. So this is an example of where only one number is possible for our solution. So look at that. We were able to go through all of the problems on this worksheet together, practice identifying and justifying, which methods would be the best to solve quadratics. So here's what you're going to go ahead and do now. You are going to submit this practice. It is called 32.4. It is our practice that you are going to submit to Schoology so that way I can see you are participating in today's notes. And then tomorrow we're going to continue to practice different methods of solving quadratics, and we're also going to build on what we already know with a couple of story problems. I know, we're getting the real life application aspect into it. It's gonna be awesome. Sweet. Okay, all right, I will see you all tomorrow. Bye.